Welcome to the Virtual Tutor Series on Core Mathematics for Senior High Schools. This is part 3 of the solutions to past SSSCE and WASSCE questions on algebraic expressions. It also happens to be the final episode in our series of lessons on algebraic expressions. If you haven't watched our video lessons on algebraic expressions yet, I highly recommend that you do so before watching this video. To begin with, let's take a look at WASSCE 2011. Objective question 1. Which of the following is a factor of TR minus PS minus PT plus RS? Solution. We have the expression TR minus PS minus PT plus RS. This expression contains 4 terms, so we can easily determine its factors using the method of grouping. But before then, let's rearrange the terms by pushing negative PS beside RS. So the expression now becomes TR minus PT plus RS minus PS. We then put the first 2 and last 2 terms in brackets and factorize each group separately. The common factor of TR and negative PT is T. So the first group factorizes into T into bracket R minus P. The common factor of RS and negative PS is S. So the second group factorizes into S into bracket R minus P. Now, let's put the factors in bracket and set it against the common terms in the brackets. So we have into bracket T plus S as against into bracket R minus P. Therefore, the factors of the given expression are T plus S and R minus P, making option C the correct answer. Theory question 2A of WASSCE 2011. Simplify x plus 1 over x plus 2 all over x squared minus 1. Solution. We are to simplify the expression x plus 1 over x plus 2 all over x squared minus 1. First of all, let's convert the division sign into multiplication by multiplying by the inverse or reciprocal of the denominator. So we have the first part of the expression here, and the inverse or reciprocal of x squared minus 1 is 1 over x squared minus 1. We can now work on each part separately. For the first part, we need to find the LCM, which is x. 1 into x is x, and x times x is x squared. Again, x into x is 1, and 1 times 1 is 1. And finally, 1 into x is x, and x times 2 is 2x. Note that x is the same as x over 1, and 2 is the same as 2 over 1. The denominator of the second part is a difference of 2 squares. And can be factorized as x minus 1 times x plus 1. Now, the numerator of the first part is a quadratic expression with the coefficient of x squared being 1 and the constant term being 1. So 1 times 1 is 1, and 2 factors of 1 which sum up to the coefficient of x, or 2, are 1 and 1. Therefore, the factors of the expression are into bracket x plus 1 times into bracket x plus 1 all over x times 1 over into bracket x minus 1 times into bracket x plus 1. At this point, we can cancel out the common factors. So x plus 1 cancels out x plus 1, leaving x plus 1 all over x into bracket x minus 1. WASSCE 2011 NOVDEC Theory Question 2B. Simplify m plus 1 all over m minus 1 minus m minus 1 all over m plus 1 plus 4 over m squared minus 1. Solution. We are given the expression m plus 1 all over m minus 1 minus m minus 1 all over m plus 1 plus 4 over m squared minus 1. As you are already aware, the first step in simplifying an expression involving the addition or subtraction of algebraic fraction is to determine the lowest common multiple, or LCM, of the denominators. Both m minus 1 and m plus 1 are factors of m squared minus 1. Therefore, the LCM of the denominators is m squared minus 1, or the factorized form into bracket m minus 1 times into bracket m plus 1. The next step is to express all fractions in terms of the LCM. M minus 1 into the LCM is m plus 1, and m plus 1 times m plus 1 is into bracket m plus 1 all squared. Again, m plus 1 into the LCM is m minus 1, and m minus 1 times m minus 1 is into bracket m minus 1 all squared. Finally, m squared minus 1 into the LCM is 1, and 1 times 4 is 4. Let's now simplify the numerators. The perfect squares can be expanded by squaring the first terms, multiplying 2 by the product of the first and second terms, and squaring the second terms. Following this rule, into bracket m plus 1 all square expands into m squared plus 2m plus 1, and into bracket m minus 1 all square also expands into m squared minus 2m plus 1. Plus 4. All over into bracket m minus 1 times into bracket m plus 1. For a better understanding of the rules for expanding perfect squares, I recommend that you watch our previous lesson on expansion of perfect squares. Now, let's get rid of the bracket by distributing the negative sign over the terms in the bracket. So we have m squared plus 2m plus 1. Negative times positive is negative, and negative times negative is positive. So that expands into minus m squared plus 2m minus 1 plus 4 all over into bracket m minus 1 times into bracket m plus 1. At this point, we can add or subtract like terms. M squared gets rid of negative m squared. 1 gets rid of negative 1. 2m plus 2m is 4m plus the lone term 4 all over into bracket m minus 1 times into bracket m plus 1. The numerator has a common factor of 4. So let's factor 4 out to have 4 into bracket m plus 1 all over into bracket m minus 1 times into bracket m plus 1. M plus 1 cancels out m plus 1, leaving 4 over m minus 1. Objective question 13 of WASSCE 2012. Multiply mk over 3m plus 3k by m plus k all over m. Solution. We have mk over 3m plus 3k multiplied by m plus k all over m. Let's first bring common factors out. mk can be rewritten as m into bracket k. 3 is a common factor of 3m plus 3k. So 3 can be factored out to have 3 into bracket m plus k times m plus k all over m. Now, Let's cancel out the common factors. So m cancels out m, and m plus k cancels out m plus k, giving us k over 3. Therefore, the correct answer is option A. Theory question 2A of WASSCE 2012, NOVDEC. Factorize completely 9a squared minus 4 into bracket a minus b all squared. Solution. We have the expression 9a squared minus 4 into bracket a minus b all squared. 9 is equivalent to 3 squared. So 9a squared can be rewritten as into bracket 3a all squared. Again, 4 is equivalent to 2 squared. So the second expression can be rewritten as minus into bracket 2 into bracket a minus b bracket close all squared. We now have a difference of 2 squares, and we can factorize it by expressing the product of the difference between the first and second terms and the sum of the first and second terms. So we have into bracket 3a minus 2 into bracket a minus b times into bracket 3a plus 2 into bracket a minus b. Removing brackets, we have negative 2 times a to be negative 2a, and negative 2 times negative b to be 2b. So the first group produces into bracket 3a minus 2a plus 2b. For the second group, we have 2 times a to be 2a and 2 times negative b to be negative 2b. So that gives us into bracket 3a plus 2a minus 2b. Now, let's add or subtract the like terms in each group. For the first group, we have 3a minus 2a to be a, giving us into bracket a plus 2b. And for the second group, we have 3a plus 2a to be 5a. So that gives us into bracket 5a minus 2b. WASSCE 2013. Objective question 41. Factorize completely m squared n minus 2mn squared plus n cubed. Solution. We are to factorize completely the expression m squared n minus 2mn squared plus n cubed. We have a common factor of n, so let's factor n out. So the expression becomes n into bracket m squared minus 2mn plus n squared. The expression in the bracket is a quadratic trinomial with two variables, m and n. The product of the coefficient of m squared and n squared is 1 times 1, which is 1. And two factors of 1, which sum up to the coefficient of mn, or -2, are -1 and -1. Putting -mn and -mn in place of -2mn, we have the factors of the expression as n into bracket m minus n times into bracket m minus n. Into bracket m minus n times into bracket m minus n is a perfect square and can be expressed as into bracket m minus n all square. So the expression can be rewritten as n into bracket m minus n all square. Therefore, the correct answer is option A. WASSCE 2014 Objective Question 37. Subtract 1/2 into bracket a minus b minus c from the sum of 1/2 into bracket a minus b plus c and 1/2 into bracket a plus b minus c. Solution. We have the sum of 1/2 into bracket a minus b plus c and 1/2 into bracket a plus b minus c minus 1/2 into bracket a minus b minus c. The LCM of the denominators is 2. Since all the denominators are 2, we will only distribute the numerators outside the brackets over the terms inside the brackets. So we have the first part to be 1 times a, 1 times -b, and 1 times c, which is a minus b plus c. For the second part, we have 1 times a, 1 times b, and 1 times -c, which is a plus b minus c. And for the last part, we have -1 times a, -1 times -b, and -1 times -c, giving us minus a plus b plus c. Don't forget that negative times positive is negative, and negative times negative is positive. Now, let's add or subtract like terms. So we have a plus a minus a to be a. Negative b plus b plus b is b. And c minus c plus c is c, all over 2. This can be rewritten as 1 over 2 into bracket a plus b plus c. Hence, the correct answer is option A. WASSCE 2015 Objective Question 8. Factorize completely 6ax minus 12by minus 9ay plus 8bx. Solution. We have the expression 6ax minus 12by minus 9ay plus 8bx. This is a quadratic trinomial with two variables. To be able to factorize it easily, let's bring negative 9ay beside 6ax and push negative 12by beside 8bx. So we have 6ax minus 9ay plus 8bx minus 12by. We can now put the first two and last two terms in brackets and factorize each group separately. The common factor of 6ax and negative 9ay is 3a. So the first group factorizes as 3a into bracket 2x minus 3y. Also, the common factor of 8bx and negative 12by is 4b. So the second group factorizes as 4b into bracket 2x minus 3y. Now, let's put the factors in bracket and set it against the common terms in the brackets. So we have into bracket 3a plus 4b times into bracket 2x minus 3y. Therefore, the correct answer is option B. WASSCE 2016 Objective Question 11. Find the values of y for which the expression y squared minus 9y plus 18 all over y squared plus 4y minus 21 is undefined. Here is the solution. The given algebraic fraction is undefined if the denominator, or y squared plus 4y minus 21, is equal to 0. The product of the coefficient of y squared and the constant term is 1 times negative 21, which is negative 21, and two factors of negative 21, which sum up to the coefficient of y, or 4, are negative 3 and 7. Therefore, the factors of the quadratic expression are y minus 3 and y plus 7 is equal to 0. If the product of two numbers is 0, then either of them can be 0. Therefore, either y minus 3 is equal to 0, which implies that y is equal to 3, or y plus 7 is equal to 0, which implies that y is equal to negative 7. Therefore, the values of y for which the given algebraic fraction is undefined are 3 and negative 7. So the correct answer is option C. WASSCE 2016 NOVDEC Objective Question 46. Simplify 1 over 4m squared minus 9n squared all over 1 over 4 into bracket 1 over 2m minus 3n. Solution. We have the expression 1 over 4m squared minus 9n squared all over 1 over 4 into bracket 1 over 2m minus 3n. The square root of 4 is 2, so 1 over 4m squared can be rewritten as into bracket 1 over 2m all squared. Again, the square root of 9 is 3, so 9n squared can be rewritten as into bracket 3n all squared all over 1 over 4 into bracket 1 over 2m minus 3n. Now, the numerator is a difference of two squares and can be factorized as into bracket 1 over 2m minus 3n times into bracket 1 over 2m plus 3n all over 1 over 4 into bracket 1 over 2m minus 3n. One over 2m minus 3n is gotten rid of. Now, let's multiply the numerator by the reciprocal or inverse of the denominator. The inverse or reciprocal of 1 over 4 is 4 over 1 or 4 multiplied by into bracket 1 over 2m plus 3n. Hence, option D is the correct answer. WASSCE 2017 Objective Question 37. Simplify the expression a exponent 2 b exponent 4 minus b exponent 2 a exponent 4 all over ab into bracket a plus b. We have the solution here. We are given the expression a exponent 2 b exponent 4 minus b exponent 2 a exponent 4 all over ab into bracket a plus b. The common factor of the denominator is a square b square. So we can bring the common factor out to have a square b square into bracket b square minus a square all over ab into bracket a plus b. We can rewrite a square b square as into bracket ab times into bracket ab. B square minus a square is a difference of two squares and can be factorized as into bracket b minus a times into bracket b plus a all over ab into bracket a plus b. Now, let's get rid of the common factors. So AB gets rid of AB and B plus A gets rid of A plus B. AB times B is AB squared and AB times negative A is negative A squared B. Therefore, the correct answer is option D. WASSCE 2019 Theory Question 2B. Factorize completely 4b squared minus ab plus into bracket a plus 9b all square minus a square. Solution. We have the expression 4b squared minus ab plus into bracket a plus 9b all square minus a square. Let's repeat 4b squared minus ab here. Into bracket a plus 9b all square is a perfect square and can be expanded into a square plus 18ab plus 81b square, then minus a square. Now, let's add or subtract like terms. So we have a square getting rid of negative a square. 4b square plus 81b square is 85b square. And negative ab plus 18ab is 17ab. The common factor of 85b squared and 17ab is 17b. So we can factor 17b out to have 17b into bracket 5b plus a. Congratulations! We have finally come to the end of today's lesson, and for that matter, the end of the topic, algebraic expressions. We have extensively covered the various aspects of algebraic expressions in line with WASSCE syllabus, and also solved ample past SSSCE and WASSCE questions on the topic. You should therefore be able to handle any algebraic expression question you come across in the WASSCE examination with ease and confidence. In our next series of lessons, we will cover the topic linear equations. Kindly like and share this video and also subscribe to the TVTL's YouTube channel in order to receive notification on future videos. Thank you for watching and see you in our next video lessons.